Okay, I want to explain to y'all how to do this Desmos activity, but as well as take the time to discuss um, how we look at graphing rational functions, and we can even look at the different properties of a rational function, its graph, without graphing it by just looking at the function. So the first thing that we do is we factor our function. So with this Desmos activity, you're going to enter in the function, and you're going to factor it, but you're not going to cancel any factors out. Okay, and so you see the format that we put that in. We don't have any extra parentheses or anything like that, just what's needed. So be careful of your format when you put it in so that it'll check properly. So now just looking at the factored form of your function, you can figure out what the whole is, the point at which, if there is one, at which the function doesn't exist. So you can find those by seeing where you have a factor that's both in the numerator and the denominator. And so in this case, you see you have an x plus 1 in both. So that means when that factor is 0, so at x is equal to -1, you have a hole in your function. And now you want to figure out the y value of this point, right? So what you do is you look at your function and you can cancel out those terms that you have in the term or terms that you have numerator or denominator, and you look at the ones that you have left, the x plus 2 over x plus 3. Plug in your -1, your x value for the whole, and solve for y. So in this case, I'd have -1 plus 2, so that's 1, over -1 plus 3, that's 2. So it's 1 over 2, which is 0.5. Okay, and so that's the actual point for the whole. Now, the vertical asymptote in this case is x is equal to -3. Okay, so what you're looking for is you're looking for any factors in the denominator that are not also in the numerator. Okay, and when that factor, that term goes to 0 is when you have a vertical asymptote. So in this case, that's at -3. Then horizontal asymptotes, you look at the exponents of your greatest exponent. And in this case, the exponent and the numerator and denominator are equal. So you're looking at the ratio of your coefficients. In this case, you have 1 over 1. So your horizontal asymptotes is y equals 1. Now, the x value of your zeros, well, that's where y is equal to 0. So y is equal to 0 when your numerator goes to 0, right? But well, your denominator does not. So again, you ignore these common factors in the top and the bottom, numerator, denominator, and you just look at the factor that you have that's only in the numerator. So in this case, that's 2. It goes to 0 when x is equal to -2. And so you're just going to write the x value of the 0. Okay. So then, and actually, let's go ahead and write that as a point. So that would be, okay, and it'll be updated in your application. So the y-intercepts, where you have a y value of 0, is when your x's are 0. So what you do is you plug in x is equal to 0 into your function, and you're going to get 2 over 3. Okay, you can write that as a fraction. Don't write it as a decimal if it's repeating, because it's going to be hard to check that. Okay, so the important thing is to write this in the proper format, okay, in order to get it to check properly. So it's going to be safest to write them as fractions. If it's not a non-repeating decimal, I will have that in there to check, but it's safest to do as. Now you'll hit check, and in yours, you'll get check marks everywhere that you have written it properly. You can, of course, do this as many times as needed, since the formatting is a little weird, to get it right. Okay, you'll also be asked to look at graphs and figure out the different qualities of the graph. You will not need to actually build an equation from this. So in this case, I look at it and I see that I've got a vertical asymptote where x is equal to 1. So that is the equation of a line that I need to write. So it's where x is equal to 1. Horizontal asymptote is where y is equal to 2, right? We can just look at that and see that. Okay. So then the whole, which is a point, we see that on our graph, that is located at -4, 1. We just write it. -4, 1. Okay. So our x-intercepts, let's see, our x-intercept, we see it crosses the x-axis right at there, -1.50, and you can write that as a decimal in this case, -1.5, 0. Oh, but it says we're gonna do it as a point, even though it says the values. And then our y-intercept. Do we have a y-intercept? Let's see. Yes, we do. Down here. 0, -3. 0, -3. Oops, just one set of parentheses. Okay, so then we can do our domain and our range. So our domain, we have where we're going to write this with a comma. We have the domain cannot be where our x value is 1 at our vertical asymptote. And it also cannot be where we have a hole, where x is equal to -4. So what I'm going to write is x is not equal. So I have these symbols up here that are not on your keyboard. You can copy paste them, Control-C, Control-V up there. So it's not equal to 1 nor -4. Okay, so you can put 1 comma -4 for that. Now I write my y is not, the range, I'm sorry, is all real numbers except for where y is not equal to, and I've got that still there, paste it, not equal to 2, and it's also not equal to the y value of this whole, which is 1. Okay, I'll actually accept it either way, 2, 1 or 1, 2, although 1, 2 is going to be a better format to do it. So you also have greater than and less than, or less than or equal to and greater than or equal to symbols if you need those. If you don't need the or equals to part, you have those symbols on your keyboard. And of course, you'll be able to check it. It'll let you know when you have it right. So please ask me if you have any questions after watching this. But just make sure that your formatting is correct. We have an equation, and then everything else is going to be a point, and then be careful of how you enter the domain and range. Notice you do not need those brackets. Okay, I hope you all do well on this.